to get our data in the correct type, right? To then perform different queries on it. And right with null, it's also working with null values or missing values or turning something into null, right? That's right. These are all ways to like basically coerce our data. So we'll start here, just connect to a database. So this is, I'm like initializing a new database. Let's see if you can see it. Here it is, crm.db. And then from there, we'll download the data. Okay, so we just have some people, it has, typical kind of, say these are our customers, right? Like customer information, first name, last name, cell phone. And then we'll write this to SQL. Oh, I guess it already saved. Well, I can just, if you get this error, you can just say if exists equals replace. So if this table already exists, we can replace it. And that should be fine. And then we can just see where we have this data. So the first thing, you can see that we are selecting data based on whether or not the first name is null, right? This is why we're getting back these in pandas, it displays as none. But if we did this directly in Postgres, you would just see null here. Okay? So lots of times you may not want to work with, say you don't want to actually see the text null, or like say, for data science, for instance, there's other things that you may want to display. It could also just like be for your stakeholder. Instead, maybe you want to see like name unknown is what's preferred. So what you can do is we can say, okay, select, let's just work with ID, comma, first name, last name. Let's just do these few for now, cell phone. All right, so we'll just select these columns, okay? And now let's say that instead of displaying null here, what we want to do is display like name unknown. I believe what we can do is say coalesce first name, comma, and then we'll put here name unknown. So now this is, let's just see what happens and we can explain it. All right, so, and we'll do all these. I guess that's fine. So you can see what happened here, right, is this is really, this column name doesn't look super pretty. Let's say as first name. Okay, so, sorry, wrong one. That's first name. Okay, so let's explain what happened here. We passed through first name into this coalesce function. So what this function does is if there is a first name present, it will just keep it as the same. If there is no first name, then it replaces it with name unknown. Let me try to do this by showing examples where where both it is present and it's not. So here's an example here. So you can see in this case, first name is present, right, Eunice? But then in this case, it's not. So this is using that, okay, it's almost like a default value. When we're not providing the value, this is what it will be set as. However, otherwise, it's just going to stay kind of the value. Okay, so that's coalesce. One thing that you can do with coalesce is you can say, one thing you might want to do is say, okay, instead of put this name unknown, why don't you just put the last name here? All right, so it's not the first name, but maybe it's close. So we'll say select ID coalesce, and then we'll do first name, comma, last name. So as first name. So now what will happen is if this value is null, right, it will use the last name instead. So let's take a look at that. So you can see that this guy is untouched, and then here, because it's null, we're using the last name. These are probably two similar things, right? We're using the last name. We're using the last name. One thing to note is this is in the right, after the word select, where we do columns. The things in columns, they're just like related to the view. Like it's related to basically what you get back as a return value. It's not changing the underlying data, right? So if we do like just select star again or select first name, we will see our data's unchanged, right? We're back to our null values. One last thing to know about coalesce is that you can provide this with this coalesce function with as many arguments as you want. So what does that mean? If we do something like this, then what happens is it'll look to see, is there a first name? If there's a first name, use it. If there's no first name, right, if it's null, then go to the last name. If there's no last name, if that's null as well, then use this. All right, so you can provide more kind of fail-safe, or I don't know, plan A, plan B, plan C, right, to this function. Okay, so this is coalesce. It's basically like, it's a good way to be able to work with, kind of like easily work with null values. When it's null, do this, right? Provide this value instead. If this guy's null, then provide this value. All right, questions before we move on from here? Okay. So one other thing that we may get is, last time we do want to oftentimes represent like similar data as the same. So what am I trying to say? In our data set, we have some empty strings, I believe. Let's see this. So we'll do pd.reachSQL, select from persons, connection. Right, select star from person. I'm going to say where first name equals an empty string. I just want to see if we have them. Oh, we don't. Is it last name? Hold on. Sorry, I'm going to cheat. This is all coalesce. Limit 10. Okay, look. This is an empty string, isn't it? I believe so. Yeah, so select. This is ID from first name, last name, limit 10. Oh, and this is, I guess it got switched to null, to none. Oh, that's a bummer. So if this were, you can see what I'm trying to do here. Essentially, where we have an empty string, I'm going to say that, I'm going to convert that to be null. So I'll give you, here's a kind of very easy example. Imagine that Enos actually is like, we want to convert Enos to be like the value null. I can do select ID, null if first name is Enos, I believe, as first name. And you see that? Now this is null. Okay, so when is that useful? Right, this is useful, right, if you have the empty string. If, say, you have like this name unknown sometimes. Sometimes people do like -9 or something like that, or -99 to represent a missing value. So in other words, you may see like a lot of different ways to represent a missing value. And instead, the first step I'm proposing is convert them all to be null. So you can say null if, the first name is Enos. And now you have both, Enos's are now null, and the null values are null. Once you do that, now they're all the same value, then you can change it to whatever you want, right? Because you can say coalesce these null values, I think it'll be this. These null values, the output here, as to name unknown. Let's take a look at this. Let's take a look. You see this? So what did we do here? The first thing we did was we saw that this name was Enos, right? So we converted it to be null, because it's null if Enos. Once we did that, then we converted the value, this null value, to name unknown. All right? So it's like a nice little trick. First get them all to be the same thing, right? Everything that should be represented as null by using the null if. Then once it's null if, now you can convert it to whatever you want. So this coalesce null if is a good combination, right? These things work well together. I feel all right? Okay, any questions about this before we move on? No? Okay, I'll briefly do case when. One thing to talk about nulls. I don't know if I made this clear before. If you do select, let's take a look at like counting things. So if I do select count star from the persons table, right? This gives me back, it will say like as number of people. All right, so we have 1,000 people here. Now let's go back to select star. All from persons. I have an as there. Okay, so we have 1,000 people. Now what if we do select count from first name? This is going to be less. Okay, the reason why is because, why is it 702? Well, because it's not counting the null values here. All right, so that's just something to know about null, is that where you're going to get, when this is calculated, if you do count star, it's counting all the rows. If you don't, if you just do the column, it's going to count where that column is a non-null value. All right. So that's kind of the last thing to talk about with null. Now the next thing to talk about is like case when, then end. When is something like this useful? This is going to be useful with like coercing our data, right? It has other uses as well, but this is a good thing to start. So let's do this. So we have our Yelp data set. Let's kind of copy it. So we have select all from restaurants, limit 5. Notice that this is, American traditional, right? But there's probably other values here that just say like we could see this. Say we want to get a sense of what are all the different categories here. How would we do that? Select all from restaurants. So we do group by category. And let's do select count star from restaurants, group by category, comma, as number per category. And then we'll do category. So I want to see the category, each category in the data set, the number per category, so how many restaurants are there of each category, and then we'll say order by number per category descending. So let's just get a sense of this. Okay, so we can already see, right, there are multiple kind of like American, right? There's American new, this is American traditional. Let's say we want to make these are all, we're just going to put them in under the bucket of American, okay? So how do we do something like that? We can use the case when then statement. So we'll do select case when category equals, let's say American traditional, then we're going to put this as American end. And this whole thing is going to be as category. Let's see if this works. And then we'll say from restaurants, limit 5. So we want to see, did we actually convert this? I think that what's going to happen here, this is not going to be perfect. I'm going to say an else statement, else category. Let's try this now. All right, so this is now working. So let me add in the restaurant name just to prove it. Oh man. Why did I put this here? Select name. All right, so this is the same data, right, that we had up top, except this time we're coercing American traditional into American. And let's take a look at how we did this. So this is the same, select name, right? Then we have this case when type of thing. So we have here is basically, this is like an if statement. So if the category equals traditional, American traditional, then it's going to be American. Otherwise, it's just going to be the original value, that category. You can see that my tendency is always to forget to put the else statement. Let's see what happens if we forget it, okay? So if we don't do this, then I believe it's basically like an if statement in Python. This is just going to be none, right? When it's not American traditional, I think we're going to get a bunch of nuns here. Let's take a look. You see that? So it's saying if it's American traditional, then make it American. Otherwise, like do nothing. Return. There's no return value here. It's just none. Okay. So that's important to know. So this should be else category. All right. So now we're back. So I just always have to kind of remember, like memorize this case when. I guess in my mind I say case when then end, but really it's case when then else end. All right. And this is kind of one statement, like it feels pretty verbose, but this is one statement that just means if. So if category equals this, then American, otherwise, right, just the normal category. One thing to note about this can be useful when, say, like sometimes you'll do this in order to perform calculations. Like for instance, we can do this. Let's say we want to count up the number of times that American traditional appears. All right, so we'll do case when category equals American traditional, then 1, else 0, as else 0, end. All right, as number American traditional from restaurants. So this is going to display a 1 every time that there's American traditional. So you see this, that's all 0. And now what you can do from there is you can sum this up. Right? Because this is now going to add up all these values. So it's going to be the number of times that American traditional shows up. I broke it. Select sum of case when American traditional, then 1. Oh, you see that? It's complaining about the as statement because this should go outside, right? We're summing up this component. So the number of American traditional is 173. Now this is giving the same result. We could have just done a group by, right? And we also would have counted up, I guess, 173. The difference really is like we can see multiple groups that we specify horizontally. So for example, the other thing you may want to do is say case when category equals American, or they call it new, I believe, then 1, else 0. So we're going to add them up as number American new. So you see this? Here you can kind of show this way, horizontally, the number of each. So this is, why am I showing this? Well, one, it does come in handy. Even more kind of common is you will read this code. You will certainly, when we move to like more advanced SQL, when you read other people's SQL statements, seeing something like this is very, very common. So all we're doing, right, is the way to do this is you can break it down by just, remove the sum, remove the aggregate, and then you can see what's occurring is that we're first just putting in a 1 or a 0 for each of the rows, and then we're adding them up, okay? Any questions about, do you guys feel okay about this? Right, this is going to be, you can call this like as, this is just a Boolean value. Is this American traditional or not? No, here it is. No. All right, sorry, none of these are American new. The other way that you'll see this is you will see you won't see the else statement at all. All right, so you just say case when category is American traditional, then 1. No else statement. Let's do the same thing here. No else statement. What does this mean? When it's there, it's 1. When it's not there, it's null. Right? I broke it again. Why do I keep take away the as? Then 1 and case 1 when category. Oh, then 1. We need the word 1 here. Then 1 and. All right. So now we have a bunch of ones. I don't know why this one is showing not a number and this one's showing none, but I think it's just a pandas thing. So basically we're getting the nuns, and then we're getting a 1. So we're only getting a 1 when it's American traditional here. I'll say this like as is American. I won't do that. So we're only getting a 1 when it is American traditional, and here we're only getting a 1 when it is American new. Otherwise we're getting nuns, right? Otherwise we're getting nuns. So now what should we do if we want to add this up? Here you can count it, right? Because this will count the number of rows that are not null, right? So one other way, this is equivalent, this is another way of getting at what we calculated previously, is using count and then simply not providing an else statement, right? So now it's going to be null. So do the same thing here, count. So this will be as number of American traditional. And this is as American new. Right, we got the exact same numbers. These are just two different mechanisms for getting to the same thing. So in one of them, the first way that we did it, we did then 1, else 0, and we added it. We did sum. The other way we did it was we did not provide the else statement. We just let it be null, and then we simply counted it. Anything here to go through again, or any questions about this stuff? It is something that mainly takes practice, but happy to talk about it. One thing to note, right, is like anything we did with this null if stuff, or this, right, we could have done that, right? We could have done this with a case when then end, right? We could have done this with a case when statement. But this is a little easier to work with in the case that you're working with null values. Here, we're handling not where this thing is null, but rather where it's, this other value, American traditional. All right? And just remember, like, using this case when, we ended by, counting up kind of like the amount of each of these categories, but we began by using this to, again, coerce our data, and that's very useful, right? I want to coerce each of these things, perhaps, to be, American. Otherwise, just keep it the same, right? Then American, otherwise, just keep it the same. And that's pretty useful. I guess this would be when category equals this, or let's just do this last one, or category equals American new. Okay, so let's see what we did. Select when the category equals American traditional, or the category equals American new, then American, else keep it the same. I'm not the best at these, so I hope it works. Okay, it seems to have worked. All right, we're coercing it to American. And we could check our work, right, by counting up if there are, right, seeing that there are no more American traditionals and no more American news, right? Okay. So what's left to move on to, so I'll deploy this work, right? I'll also deploy the Postgres data base, the data types. If you haven't finished the querying lab, obviously also work on that, okay? And the modeling practice, so you guys have a number of SQL things to work on. Cool. Let me put you all into breakout rooms. All right, so we have the pilot, and you just think about like objects, right? Our tables line up with like classes, right, that we would have if we were doing Flask. So you can just think of like kind of standard, what do we need? Okay, well, we're managing like pilots and what flights they're on. So we probably, we definitely need like pilots. And then maybe the next thing you think about is like, all right, well, a pilot, has many flights. So you have, well, here's my flights, and here's like the origin and the destination. Kind of pretty quickly after you think about this, what you're doing, remember what we kind of want with database design is we only want to store our values like once. So this works well for like an ID, right? Or for like a pilot, right? We have like the name, like Bob Smith, Fred Simpson, whatever. And these are all different individuals. With like a flight, well now we're gonna have, flight from New York to LA, on Monday. And then we're gonna have the same thing on Tuesday, right? So all of a sudden, this is repeating, right, a lot. Like we know like Southwest or whatever, right? They advertise, we do this flight like X number of times a year. So this is the idea of a route. So now we need like some sort of route here. So we have routes, and actually that is what's gonna have maybe the origin and the destination, right? So now I'm gonna have a flight belongs to a route, has a route ID, and a route has many flights, I'm guessing. And then a pilot, this is a pilot kind of, do I want to associate him with the route? Like if we do this on the pilot, say put a pilot ID here, that's not going to work, right? Because we know a route must have many flights and it also has many pilots. So I would probably put on the flight, have the pilot ID here, and maybe there's some sort of co-pilot ID here. Okay, so flight, we know there's only 2 max. I kind of told you that. So that's why we can just store these directly on the flights. If there was like anywhere from 1 to 5, then I would probably, make a separate table, like a join table, so that we have a flight has many pilots and a pilot has many flights. But in this case, we just have 2, so we're okay. So, okay, so now we have this route ID. This route ID kind of tells us where we're going, the origin and destination. This origin and destination, like what should they be? Probably airports. So this would be origin, airport, and I would just put like airport ID. And basically what you think about, like it could just be, you could just have, and then I'll do destination, airport ID. So why do we, why when I put ID here, I'm implying that there's going to be an airports table. So now the question is, what justifies there being an airports table? And what justifies it is really like, well, are there like multiple attributes of an airport that I'm going to want to keep track of, right? So for example, we could have just stored like LAX, right, and JFK here. But what I want to keep track of with an airport is, right, like the city, probably. And that seems pretty valuable, right? And I can't just do, I can't just store the city directly here because a city, I don't know which airport. If you say New York, or do you mean LaGuardia or JFK, right? So we're now saying a flight is associated with a route. A flight belongs to a route, right? A route has one origin airport and one destination airport. And an airport belongs to a city. In general, like every database you work with that is at least like a OLTP, meaning like it's like powers Facebook or whatever, or Instagram, they will have a separate table for cities, okay? It's not just going to be like Chicago or Philadelphia here. They're going to have a cities table that will have like a name. And then for state, they'll say a city belongs to a state ID. So you should get used to writing this out. It seems like pretty straightforward and like, all right, now for the simple concept of where an airport is, I'm now creating these other tables. But this is the way a database is going to be structured, right? Why? Because if I put, I don't want to rewrite, New York multiple times, just like hard code it here, right? When you see repetition down the columns of a database, that in those values, meaning I see New York multiple times, that should raise some alarm bells in you that, okay, maybe I should be splitting this out. So this is really like the state ID, and then I have a states table. And notice this is, if we did Foursquare, I can show you all my code for like Foursquare. This is how Foursquare would be organized as well. For like the venue has a city, the city belongs to a state, etc. And this we'll stay away from the country for now, but we could have put that there too. So yeah, it does kind of grow outwards, but you kind of, this should be somewhat intuitive. You'll see it again and again. One thing to keep track of, so we have this idea of a flight, and a lot of you put on this flight. Well, this flight has like a scheduled time. We have like an arrival time and a departure time. But one thing I would say is like, well, there's like the time on the ticket, but then there's the actual takeoff time. And this may seem like, all right, like I'm being like nitpicky or something like that, but like when you do an interview or when you like even design a project or do a take home, like they're going to treat you like a coworker, and they're going to want you to have the same mindset that they have, right? And their mindset is going to be, okay, well, like we're doing this for American Airlines, and if all we're doing is tracking like the time on the ticket, we're missing a ton of information. So so in other words, what we're getting at is that there's a difference between when we say the flight's going to take off and when it actually takes off, right? Which means that this is not really the flight. This is probably the scheduled flights table, okay? And this is like what, are the best laid plans, but not actually the flight. So the actual flight is now like, when does it take off? And I would say here's a flight, and a flight belongs to a scheduled flight, right? This is the plan, and then this is actually what happened. And what I'm thinking of down here is like, what can change? Obviously, like the actual arrival time, the actual departure time, that can change. Can the pilot and co-pilot change between like what I schedule and what happened? Well, yeah, right? Someone gets sick, whatever. So I'm probably going to put this here, right? I'm not duplicating my data here if this stuff can change. So this is the actual flight. One thing I started to do is I was like, all right, well, I guess there can be a delay. But say there's like 5 delays on this flight. Like they say it's going to be half an hour, and then they say an hour, then I'm losing data here, right? Because I'm only tracking the original plan and the end result, but nothing in the middle. And that probably really matters to like customers and to an airport or to an airline. Like what matters to them? Like what matters to me as a customer? Well, if they tell me this thing's going to be delayed, like before I even leave for the airport, that's less worse than if they tell me it like 5 minutes before the flight's going to take off. So in this, maybe I'll have like a delays table. And this was just I didn't do this the first time but maybe we have a delays table. We need to have like probably the scheduled flight ID again. So associated with the scheduled flight ID, we have, the announcement time. Like when do you tell me this thing is delayed? What's the revised time? Here I kind of debated about should it be the revised time that we're storing, like the new planned time for departure, or should it be like the amount of delay from the previous, like is it like a 30-minute delay that I should be storing? I don't know, honestly. Like I'd have to think about it more. The other and the reason. This reason, again, like if you kind of think about like now like an Excel spreadsheet of delays, my guess is the same reason is going to show up again and again. It's like categories with our Foursquare venues. Like the reason was bad weather. The reason was, like the engine. I don't know. So we probably have, this is actually in like real life, we probably have like a reason ID. It's probably not a great name for a column, but so my guess is there's like a reasons table. right? You want to imagine like this thing exists a lot. It's been worked on by a ton of engineers. How does it probably look in real life, right? So, and here's the text or something. And it probably also, to be honest, this thing probably has like a reason ID, and it probably has like a category ID, where the category is like equipment or weather or something like that, right? So the reason might be, just to give an example, might be like wind, but the category ID is the one related to weather. And there might be another, reason, which is like, rain or blah, blah, you get the idea. So a reason, like the actual reason probably relates to some sort of category. Okay, so now we can do, how do you come up with this? You have to kind of take the business context into account, right, when you go through this. Sorry, this is like what I had finally as my result. Sorry, was this one. Pilot has many scheduled flights. Scheduled flights has a route ID that has the origin, destination. Then we go down the line here with airport to city to state. Then I started thinking about, okay, we probably have this scheduled flights is related to the actual flight, and then we have a delay. All right, like a table of kind of, this delays table is really like events, like tracking change over time, or like history. Anything I want to like track the history of, you'll see this kind of idea again and again, where there could be kind of like multiple changes, right? That's the problem we were running in here, is if without this delays table, we're just implying basically one change. Here's what we originally thought, here's what ended up, and we're missing like the various changes in between. Okay? Where are we doing that in another case, perhaps? The planned pilot, the ultimate pilot, right? Like maybe there were, multiple attempts at scheduling a pilot, and now we're just getting what we planned and what we ended up with, but we're missing every step in between. So you're just always, I don't know. Well, we're going to practice these a lot, but you really want to think through these, and you want to think through like, all right, well, what questions, do I want to answer? Like, I'm an airport, I'm in charge. What are people going to want to keep track of, and how do I do that in a way such that we're not like we're following our rules of database design, right? So that we're not repeating any information, right? We have this city ID and state ID, etc. Okay, we're over. So thank you guys. I'll see you all Sunday. Have a good night. Yeah. Like they should almost be able to give the lecture,
Okay.
So it's like, okay, what's the, if I'm asking you what's the difference between this and this, right? We'll break it down for you to explain it, but they can see already, right, the difference. So, right, okay, so with aggregates, we're answering the question as to tell me the average, and it does give me the answer. But with window functions, now, while it gives me the answer, we're not removing the information about each row, right? There's no way for me to if I'm asking the average transactions over the entire data set, that's going to lead to just one row. Now here we have average transactions, but we still are also, keeping the rest of the information in each row. So I still have the number of transactions. So why is something like that useful? Well, now I can compare, right, the average, the number of transactions compared to the average, right? This is 900 below the average. Like that's a question we can answer here that we can't do there, right? And we can imagine that that's pretty valuable for us to know. So I'm, right away, it's just like, here's the difference, here's why, right? We want to know this. And then, okay, so how does this happen? So in the window function, the key thing is, we're still doing our aggregate, but then we're saying, once we put this word over, I guess, that's now going to keep continue to have the number of rows, right? Like, or not reduce the dimensionality is the way I normally put it, right? We're stuck with the same number of rows. So here, and you can see I just say that. So what's the difference? We just add the over keyword.
Yeah.
But in the same thing, but it does not reduce the number of rows. Okay. And now we can move on to this idea. So why is this useful? Right. Take a look at this thing. Here we can kind of do the difference from the average. So all of a sudden, like now, even though they haven't learned a lot about window functions, they feel like they have because they're getting some use out of it, right? We've just added this, we've just added this kind of value added, this new column that's useful. We might imagine like plotting it or something like that. Okay, so and then now I finally introduced the idea of a window. So the window is the group of rows to consider. So we kind of, we're in my head, at least as a teacher, I'm thinking back to like, all right, I can always lean on the comparison to group by again, Okay, so we do not specify in the above query. So okay, so the reason why in this, so notice, so now you can almost compare it to the above. So in this case, we're partitioning by the store number. So notice here they're both store number 1. So because of that, we're going to get the same average per score. Here, notice we get a different average. And this is the same thing that we got previously. It's just that in this case, there really was no window. What was the window in the first example? The entire data set, right? So this partition by is literally separating us into different windows. So that's enough for a lesson, because we're showing them, okay, what's the main kind of takeaways from here? It's that, 1, we're not reducing dimensionality, right? 2, we are able to calculate average per group, right? But we keep the number of, you can see I'm slowing down because this, as we mentioned, right, this difference is going to be, you're going to have to hammer home this difference again and again, right? And you're going to probably have to show it, so this is why this average per store, we could say where store number equals 1 or store number equals 2. Maybe, can we do that? Oh, man. Sorry. Say select all. Where store number? We can just do in, I guess. Maybe we can do that. Now I must have an extra average transactions partitioned by store number.
What's the error you getting?
I'm getting it says I'm getting something I have wrong with this parentheses. Sent near.
Or store number and
store number, average transactions over.
Where store number and.
Could I do, let's put it back. I used to have this, where store number equals 2. No, that's breaking 2 as well. Does this break? These are all. How about this one? Oh, you know what? Maybe window functions doesn't work in Colab. I think there's something like that. I wonder.
You just ran one though, did you not?
I thought I did, but no, I guess I didn't. This works. Yeah, this is something in Colab. I guess it doesn't work. It will work in here in Jupyter Notebook, I believe. Let's take a look.
Yeah, it's been working for me.
Yeah, so okay, this is going to be annoying for you. Yeah, you're just gonna have to tell them to clone it down, that it won't work in Colab. Let's just copy this.
Okay, so I'm actually gonna have to.
You have to go. Say that again, Micah.
So I'm actually gonna have to push it up. I think initially we said before I was just gonna share my screen.
They can work through just my kind of reading. They don't have to. They don't have to go through you can just give the lecture. If I deviate from the point is they're getting it in 2 different formats,
Oh, true. Yeah, okay. I'll push it up then to GitLab. You're using GitHub or GitLab? I forgot.
GitHub. Yeah.
Whichever one.
Yeah.
Okay.
So it worked for you on.
I'm using
Jupyter
VS
Notebook,
Code.
and it worked fine.
Yeah, that's how you have them
Yeah.
you have them using VS Code now, right? Or
Yeah, I mean they can use. I think for these, I have like they can just use notebooks. That's fine. Some of them will choose to use VS Code. That's fine too. Let's just take a look. Okay, so this actually works. Where store number equals 1, or store number equals 2. So this, and let's not do any limit. So basically always look, so this is what I would do, right? Because you're just looking for ways where you can show them as much as possible. Like now we have to make this as you know, you're always making stuff as easy as possible. So here you can just see it. Notice that all these ones are the same, right? That the average per store here is the same. And then once we get here, this is different. So what this is the average per store where the store number is 1. And that's our window, right? Our window is the stores that are 1. And our window is determined by each store number. And the way that we specify that is we say that we're partitioning by store number, right? It's going to take them a while. They're going to have to then make the connection. Oh, okay. So yeah, like this is just like group by, right? It's just like group by. If we did group by, we would get these 2 different numbers as well. But here we're not reducing the dimensionality. We're still holding on to each original row of the data. Okay, why is this useful to us? Well, think about it. Here I have, these are the number of transactions per store, the number of transactions per store per day. And now I'm comparing the number of transactions on this day versus that store's average. So the transactions that this store had today versus that, right? So we can just explain the concept and then go straight into why. Yeah, and you're hammering home, right? So me explaining the concept is I'm showing it. Okay, I kind of get it. Wait, but then how is this different from group by? It's different because remember, group by reduces the number of rows in the data set, right? So nothing I'm doing uses hardly any terms. Like the only term I talk about is window, and even with window, you have to make sure that we can see it. We can see it in the result of the data right away.
Okay.
So there's 2 different ideas. One is here's the result of the data, and then here's how we did it. Here, how does SQL know to do this? Well, we said to partition. We said to partition by the store number, and that should feel like group by, right? Okay. So previously we did group by. Now we're saying partition, and now the next question is, right? Well, what's the difference? Oh, well, the difference is, group by we'd only get 1 row per, and 1 row per store. Here we get, we still hold on to the same number of rows. Wait, and why do we care? Well, that's valuable because now I can see, this grouping by this store. I get the average per this store, and now I see how much does this differ from this store's average. How many fewer sales did this store do than it does on average each day? And now we go to store 2 and we ask the same question, right? How many fewer did it do? So right, every little concept, I guess you're making visual. Okay, show the result. Now we have the second thing to explain. Okay, here's how we do this, right? And now we have the third thing, right? So even though this is very slow, there's still 4 different ideas with each step to go through. Okay, here's the result. Here's how the result differs. Here's how the code differs. Here's how this differs based on group by, or our comparison point. And then this is why we care. We want this thing to begin with. Right.
Okay.
So that's why you move through this stuff just so inch
slowly.
by inch. Because with each step you have to go through 4 different explanations. And they should be, like I said, the key thing is they should be able to give the lecture for you. You tell me the difference. They're just confirming You're just drawing the connection like in their brain, but they could have done it themselves, right? No,
So
here's the
basically,
difference.
just keep the intro like real short and just get
You
into
can the intro.
just keep it in a code that they can
You're
see.
not telling them what a window function is. Hey, we're going to learn about window functions today. No, because you're just. I mean, that is a way of doing it, but like there is a benefit to doing it, which is okay. You kind of like get them asking the question, but that really only works in certain cases. Like it works where like they already want to. I can give other examples. I don't really see it working in this case. You know, like for instance, yeah. So I wouldn't really introduce it. Like say like here's a window because I can't think of a good way to describe what a window function is without you seeing it. To
Yeah.
me, you know,
Okay.
like here you can kind of so the way I would start with it is we saw window function is kind of like group by. Remember what group by is. Show it, right? You have to highlight the point, you know, and then now window function actually gives us the same answer. So in a way, you're saying, hey, here's this hard concept, but it's not any different, right? So we're still able to calculate the average. And again, notice like I didn't do a part like in the first kind of part, we didn't introduce anything about partition by because we're trying to avoid that concept of window altogether. You know, to start with, we're going to lead up to it.
Okay.
You know what I mean? So we're showing the simplest version possible that still kind of still adds some value, but you know, just explaining that is going to be now I'm leading up to the even this, right? We didn't go for this right away, right? That's too
Yeah.
much.
Yeah.
It's too much.
Okay.
Yeah.
Okay. Thanks for that.
So maybe yeah, okay.
I could. I'll have you a better outline, or out
Or
with the
revise.
changes you gave me. I'll have you something by tomorrow, or I
Okay.
can do it. I don't know if you have on Friday to